Hello everybody, this is Carmichael the Cat, and welcome to your 19th Lua tutorial. This is the second part of our strings tutorial, and you'll remember from last tutorial we went over all the functions in the string library, and in this tutorial we'll be going over these patterns. So before we start an example, let me explain what these are, just in general. So in some functions in the string library, instead of just taking a normal string like L or hello world, they accept patterns that are these, obviously. And basically what these patterns are is they're just a letter preceded by a percent that codes for a group of characters instead of just one that a normal character would. So for example, a dot, this one actually isn't preceded by a percent sign, this codes for any character. So if we said string.gmatch and we just said dot, and we saved it, we should, I closed the file, or never opened it. So we go to our file and run it, we get hello space world. So what we've done is we've just iterated over every character in the hello world string. So this one codes for all characters, and then the other ones, there's this one, %A, that codes for all letters, so anything from A to Z. And then there's C, which codes for control characters, which is \n, \t, \0, those kinds of stuff. %D codes for digits, 1 through 9. I'm not sure why it's not %I, which codes for integers. But they chose %D, probably because that's what they use in C too. Then there is %G, which is any printable characters, so I think that means anything but the control characters. I spelled characters wrong here. Gotta change that, sorry. Then there's %L, lowercase letters, %P, punctuation, %S, spaces, %U, only uppercase, %W, alphanumeric, which I think is the numbers, the byte codes that we went over in the string.byte and string.char functions. And then there's hexadecimal, which is 0 through F. So now let's show some more examples with our string.gmatch function, and then we'll do even more examples with other functions. And we'll get to all the rest of this stuff in a minute. So let's say s:\gmatch %A. So this is just letters. So what we should get is we should get hello world, each letter on a different line, but we shouldn't get a space like we did with the period. Yep, we just get hello world, and there's no space between hello and world. And remember that when we had the dot there was a space. So now let's do %, actually we don't need to do everything. If we do %S, we would just get a space. And I think that's enough examples for this. You hopefully get it. So another thing you can do with patterns is if you give it a capital A, or a capital letter, the capital version of whatever the percent, whatever comes after the percent, I said that badly, sorry. If you give it the capital version of that, then you will get the opposite, or complement to it. So if we put %A, we would get everything but letters. So let's just add a bunch of numbers. Save this. Run it, we get space, and then 1, 2, 3, 4, 5, 6. So we got the space here, because the space isn't a letter, the space here, because it's not a letter, and then these numbers, because numbers aren't letters. So this works for all of these, except the dot, because you can't really have not any character. That would just be nothing. So it works for any of these, so you could have not control characters, not digits, you just give it the capital version. So now let's do a slightly more complicated example with string.match instead of string.gmatch. So let's change the string to the date is : and we'll use the same date from the last example. We'll reuse the date 04-05-2014. I think that's correct. It doesn't matter though. So now let's also delete this, and we'll say print s:\match That's spelled right. Yep. S:\match, and remember this takes two parameters: the subject string, which is taken care of here, and the pattern we want to match. So instead of just giving it a string, let's use our pattern matching functions. So we're going to say %d, and then we're going to put a plus after this, and I'll get into that in a minute. Then /% %d plus /%d plus. So what this plus after the pattern is it's saying that we want one or more repetitions of a digit. And it works for all the other pattern matching characters too. So we want one or more repetitions, and if we don't get... So if you don't have this plus, it'll only match one digit, so it would just say 0, and then it would look for a slash, not find it, and just say that there's no occurrence of the pattern in the string. So we say plus to say that there can be between 1 and infinite digits. And there are also more of these. That's what these are. And we'll get into those in a second. But let's run this. I close the file. Of course. If we run this, we get 04-05-2014. Why did I minimize that? Get rid of it. So we're matching the date, and string.match found the date, isolated it, and printed it out. So that's another use for pattern matching functions. And just to... Actually, no, that won't work. I was going to use capital D's, so it would just say the date is. But we can't do that yet. We will be able to in a minute, though. So there are a few more modifiers that you can put after a pattern matching character. There's the star, which means 0 or more repetitions, and it takes the longest sequence, which we'll go over in a second. There's the dash, which is the same 0 or more repetitions, but it takes the shortest sequence. And then there's question mark, which means optional. So to show the star and minus, we're going to use a different example. So that example is going to be matching comments in a C program. So if you're not familiar with C, a multi-line comment, which is what we're going to be matching, is a / and then a star. So we're going to still use string.match, and what you may think of doing is saying / and then you'd say %* to show that we want to actually match a star character, not match 0 more repetitions of the /. So you'd say / %*, and then you'd have dot, and then the star, and this means 0 or more of any characters. We say 0 or more, not 1 or more, because you could, I don't know why you would, but you could just have open and closed comments in a C program. There's no reason to do that, but you could if you want. And then we have %* again, to show that we actually want to match the character star, and then another /. So this seems like it would work, and in most cases it actually will, so let's change the string. And let's say, just say comment, and that's just the comment syntax in C. So now if we run this, I need to reopen the file. Where is it? Here it is. Now if we run this, we get comment. So it matched it, and what we should probably do just to prove it that it worked, let's just add some random characters. That was a lot before and after it, just to show that it's only finding the commented out part. Go here. Oh, wrong file. If we go here and open it up, we just get comment. We don't get the random characters before and after. So now let's do something else to show that the .* works, so 0 or more repetitions of any characters. So if we delete this and save it and open this, then we just get the beginning and end comment symbols. I'm actually going to close this file so we don't get confused again. And if we put a plus here, it actually wouldn't work. So if we're saying 1 or more repetitions of any character, which there are no repetitions of any character here. Then if we run it, we get nil because the pattern wasn't found. It found the beginning comment, but then there were no characters there. So it says that the pattern wasn't found. So this seems like it works fine, but there are actually some situations where this pattern wouldn't work. So let's get rid of these characters at the end, and we can put comment back. So now let's put something else here. Let's put another comment. So we'll just say comment, I spelled comment wrong, not that it matters. Comment 2, I spelled it wrong again. And then we'll end the comment. So now let's see what happens if we do this. So we run it, and then we get comment, and then close comment, and then comment 2. But that's not what we want. We just wanted to match one comment from the program, which doesn't actually exist, obviously. We're just using a string. But we just wanted to match from here to here. We don't care about this second comment at the moment. And the reason it's doing this, matching from this to this, is because the star means longest sequence. So it will find the longest sequence it can of / star and then any character. And keep in mind, this still means any character. Those are characters. So this is the longest sequence of any character it can find, and then closing comment. So if we want to find the shortest sequence, so just from the first open comment, and then some amount of any characters, and then the first close comment it can find, then we just replace the star with a dash. So if we save this, then we just get that one comment, because it found the shortest sequence rather than the longest sequence. The last modifier is the question mark, which means optional. So let's change the example again. We'll actually just do a simple one. We'll say a question mark, or no, we're not. We'll just say B, just a random letter. And then the pattern, we're going to say a %A question mark. So this means one optional letter, and this is one letter, so it should return B. Yep, we get B. And if we just have an empty string, so then it will return nothing. Or not nothing, but an empty string. And if we just put %A, then it would actually return nil. So that's what the question mark does. It just means that whatever pattern you're trying to match is optional, so it doesn't have to be there. Now let's move on to charsets. So what a charset is it's something that allows you to create your own patterns instead of just using the predefined patterns here. So to use it, let's change this function to string.gsub. So to use it, you open square brackets, we'll delete this, and then you put any characters or patterns you want to match in here. So we're going to match vowels, so we'll say A, E, I, O, U. And then you could also put capital A, E, I, O, U if the string had capital letters. And then for the second parameter, we'll just replace it with an X. And we'll put our generic example hello world back. So what this is doing is it's finding all vowels, so A, E, I, O, and U, and it's replacing them with an X. So there's no predefined pattern for this, so we had to create our own, so we used a charset. So if we save this and run it, we get hello world, but all the vowels are X's. Also, if we wanted to, say, replace all letters that aren't vowels, consonants, I could have said that in a simpler way. If you wanted to replace any consonants in the word with X, then you could just put the little caret thing. I don't know what that's actually called. That's what my 4th grade teacher called it, and I always called it that since. But you can put this here, and that will say anything but these characters here. And you can't just use capitals because A is an actual character, and all of these other things are actual characters. You can only use capital letters to say you want the opposite of that in these simple patterns. So we have this AEIOU and this what did I just do? New view into file. I don't know what that does. I probably messed something up. So now we run it, and we only get the vowels in hello world. So this is how you get the complement or opposite of something in a charset. So now let's go over two more modifiers, but they are slightly different than plus, star, and dash. They are the beginning and end modifiers. So what the caret thing means is that it will only match the pattern if it's at the beginning of the subject string. So it won't match it if it's in the middle, and it won't match it at the end, obviously. It has to be the beginning of the pattern has to be the first character in the subject string. And also, there's the $sign. I just thought of this. I don't know what you would do if you live somewhere where the keyboards don't have the American $sign on it. So you'll have to figure that out yourself if you don't live in America or maybe Europe. What the $sign does anyway is it only matches if the pattern's last character is at the end of the string. So if it's the beginning or the middle, it won't match it. It has to be at the end. So let's show an example of this. We can change this back to string.match. Match, and let's change this back to, alright, let's change this to, we'll keep hello here, and let's just put a number at the beginning. 1, 2, 3. So we can get rid of our X parameter, and we'll delete the charset, and we'll just say, we'll caret thing, and then we'll use a charset. We'll say plus minus, or not plus and equals, plus and minus, and we'll make it optional. And what we're saying here is that you can add a sign to the number if you want. So you can say, we could say plus 1, 2, 3 or negative 1, 2, 3. Actually, let's leave it as negative 1, 2, 3 just to show that. But it's optional, and that's why we put the question mark here. So we'll have that, and then we'll have %d plus. So let's go through this character by character again. We have the caret, so that means it must be at the beginning of the subject string. We have a charset with plus and minus in it, so that means the pattern will search for a plus or a minus. And then we have the optional, which means it doesn't have to have the plus or the minus in front of it. And then we have, whoa, did I just drag that character? Cool. And then we have the %d plus, which means one or more number. And we're not using one or more numbers, not number. And we're not using star because for it to be a number, it has to have a number in it. So basically, this is just matching a number at the beginning of a string. So if we save this and we run it, we get negative 1, 2, 3. And then we could also just make it 1, 2, 3. It would work just the same. And then we could also say plus 1, 2, 3. And again, it would work the same way. But what if we only wanted to match a string if the string only contained a number, so there was no hello after it? Then we could put the $sign after it. So let's save it and then try running it again. We get nil because the pattern wasn't found because the number, it begins at the beginning of the string, so it meets this requirement, but it doesn't end at the end of the string. Hello is at the end of the string. So it doesn't meet this requirement, so it returns nil. But if we get rid of hello, save it and run it, then we get 1, 2, 3. And also, if we just put a space here, then we don't meet this requirement because it's not at the beginning of the string. Spaces do count, so don't make any typos. So it returns nil again. So what this pattern is saying, again, is that we want a string that only contains a number, and then this is just a number. So now let's move on to two more patterns that we have. The first one is %b, which means balanced string. And I don't know why it's called a balanced string. Yeah, I can't think of any reason it would be called that. but I'll explain what it does. So let's put hello world again, but this time world is going to be in parentheses. Actually, let's make it curly brackets. I don't know why, I just like them better. So now we're going to say string.match, and we're going to say %b, and then after that we're going to have open and closing curly brackets. So a balanced string basically says match part of the string between this first character and this last character. So it'll match anything between two sets of curly brackets. So if we save this, we should just get world in curly brackets. So what a capture does is it allows you to kind of yank out a part of the string and use it as a return value from string.match or some other functions that we'll go over. So let's change our string. We're going to change it to a variable assignment. So we'll say, actually we'll just say var equals, and we'll say hello. And notice that I use single quotes instead of double quotes, because if I had used double quotes it would have ended the string. So use single quotes here. Actually, you know what, we can't do that because it'll make the string matching a lot more complicated. We'll say var equals 50. That's a bit simpler. So what we're going to do is we're going to get the variable name and the variable value, and then string.match is going to return those. And the way we're going to do that is we're going to have open parentheses. We delete that. So we have open parentheses, and we'll say %a plus. So this will be the variable name. And then we have %s, so a space, and we'll say %s star, so, or %s minus, because we're looking for the shortest sequence. So we're looking for, we can have one or more spaces between the variables, so we can just put a bunch of spaces there. So %s minus, and then we have an equals. There's no equal doesn't do anything in pattern matching strings, so we don't need to have a % in front of it. And then we can have %s minus again. Actually, I don't know. We don't need to use minus. We can use star. Yeah, star should work for this. And then we're going to have open parentheses again, and we'll say %d plus. So what we're doing is this entire string is our pattern. So we're looking for one or more characters, 0 or more spaces, an equal sign, 0 or more spaces again, and then a number. So we're assigning a number variable. And we can add a few more spaces here. We don't. Actually, let's put no spaces just to show the star again. But back to what the pattern does. What's different about this is that we have parentheses around the %a plus and the %d plus. So what these parentheses say is it's saying that we want to capture this one or more characters and these one or more digits, and we want string.match to return those, and that will return them to x and y. And it would actually be easier if we just printed it. So print string.match, and sorry if you heard my phone go off just then. So if we save this, we should get var and 50. I hope I didn't close that file. We didn't, so we get var and 50. So captures allow you to yank out a part of a string and get string.match or other functions to return it. So another way we can use captures is in string.gsub. So to show this example, we're going to be reversing adjacent characters in our classic hello world example. So we have hello world, and we're going to change this to s:\gsub. And for the first parameter, we give it our pattern to look for, and we're going to have two captures, one of any character. So we have any character and then any character, and they're both captured. And then for the second parameter, what we're going to replace it with, we say %2 and then %1. So when you use captures in string.gsub, instead of returning those captures, you can use the captured values in the third parameter of string.gsub, and to access them, you just get them by the order which you captured them. So this would be 1 because we captured it first, and this would be 2 because we captured it second. So what we're saying is find one character and then another character, and then replace the first character with the second character and the second character with the first character. So if we save this and run it, then we get EHLL space OOWLRD. So it switched all the adjacent characters around. But that's how you use captures in string.gsub. So the last thing we're going to go over is replacements. So instead of having a string as the third argument to string.gsub, you can also have a function or a table. And if you give it a function, then it will use the captures from it'll use the captures in the format string that it found in the subject string as the parameters to the function. And if you give it a table, then it will look up the captures in the subject that were found in the subject string and find those values in the table. So we're going to use an example with the table. We'll say, this will make sense in a minute. We're going to say name equals value. So we're going to have another variable assignment. And we'll say name equals var and value equals 50. I don't think we actually need it in quotes, but just to be safe. And then in string.gsub, we need a new pattern, so we're going to have $, and this doesn't mean that since the $sign isn't at the end of the string, it doesn't mean that it's only matching at the end of the subject string. And then in the capture, we're going to have percent, we'll say period plus. So any character plus. So it'll look for a $, and then it will look for any character plus, and let's say any character that's not a space plus. So we'll say %s plus, because we don't want the spaces to be included. So it's looking for any character that's not a space, and that's not technically proper variable naming, but it doesn't matter for this example. And then we're going to change this parameter with _G. And this is just a table that holds all the variables in the current scope of the program. So what this is going to do is it's going to search the subject string s, and it's going to look for a $, and then it will look for, actually, you know what, we need to do %w for this. I did this wrong, sorry. So it'll look for a $, and then it'll look for a word, and that word is name. So then it's going to look up name, because the word is captured. It's going to look up name in the _G table, which is all the variables that are currently active in the program. And it will find name here, and it will replace it with var, because we're substituting it because we were using string.gsub, not match. And then it will do that again with value. It'll do the exact same thing. So we save it and run it, and we get var equals 50. So that's all for this tutorial. That probably comes as a relief to you. This has been quite a long tutorial, sorry. I split it up into 2 parts, but the second part still ended up being much longer than I wanted it to. But it is a lot of information, so I encourage you to watch the tutorial again if you are confused about anything, or at least watch the parts you're confused about. You don't have to watch the whole, I'm guessing this is going to be 20-minute tutorial all over again, just for one part you didn't understand. But keep going over it until you understand it, and I recommend copying this table here somewhere, because it's hard to memorize all these characters, and I have this table in my book on Lua that I have, but if you don't have that, I highly recommend copying and pasting all this somewhere else. Or you can't copy and paste it from a YouTube video. I'm an idiot. But copy this down somewhere so that you can save it and you don't have to go back to this tutorial every time you want to use the string library. But yeah, that's all for this tutorial. In the next tutorial, we'll be going over the last of the Lua libraries, the OS library. And then after that, we may have one more tutorial just to kind of go over a few functions that I never went over in detail and just tie up any loose ends we have. And then after that, it's on to the C library. So see you in the next tutorial.